sparks a twisted game. Touch the future, leave the flame. Forget the echoes, love the shame. Oh, I don't know where I begin. Oh, I don't know where I've been. Simultaneous stimulation, erase the past with no hesitation. Selective forgetting keeps me alive. One step forward, memory deprived. I know where I begin. I don't know where I've been. Delete the bitter taste. Rewrite, there's no waste. Blank slate, brainwaves in a race. Who am I in this time and space? Delete the bitter taste. Rewrite, there's no waste. Blank slate, brainwaves in a race. Who am I in this time and space?
Abstract: dementia is a debilitating condition characterized by progressive cognitive decline. Evoked potential EP measurements offer valuable insights into neural functioning in dementia patients. However, these measurements can be marred by various demerits, hindering accurate diagnosis and treatment monitoring. This paper proposes a novel approach that combines simultaneous stimulation and selective forgetting to address these EP demerit challenges in dementia research. Simultaneous stimulation involves delivering multiple stimuli concurrently to elicit a more robust and informative EP response. Selective forgetting techniques, inspired by machine learning, would then aim to remove unwanted noise and artifacts from the EP signal, specifically focusing on demerits prevalent in dementia patients. The paper will explore the theoretical underpinnings of this approach, delve into potential implementation methods, and linguistic nervous system benefits for dementia research. This includes improved diagnostic accuracy, more sensitive tracking of disease progression, and potentially the development of onset dementia biomarkers based on refined non-organic EP signals. By combining the power of simultaneous stimulation with selective forgetting algorithms, this approach has the potential to significantly enhance the utility of EPS in dementia research, paving the way for more effective diagnosis, intraoperative monitoring, and ultimately, improved patient outcomes. Lay summary: the arcuate fasciculus, a key language pathway in the brain, can adapt and change or rewire in response to certain conditions, like language disorders. By understanding how this rewiring occurs, we can potentially develop new treatments to help individuals with language difficulties. In this study, we use cutting-edge techniques, like simultaneous stimulation and selective forgetting, to uncover the underlying mechanisms of this neural plasticity. Keywords: early signs, dementia, evoked potentials EPS, signal denoising, machine learning, intervention monitoring, readiness diagnosis. Simultaneous stimulation and selective forgetting of evoked potential demerits from dementia. Thus, an inhibition center developed below what in humans is the temporal lobe, to turn off much of the functioning of the reptilian brain, and an activation center evolved in the pons to turn on the R complex, but harmlessly, during sleep. Carl Sagan. Apoptosis and pheroptosis are two forms of programmed cell death in cells. Apoptosis is a more controlled process, while pheroptosis is iron-dependent and can be particularly damaging. Mammalian forebrain refers to the front portion of the brain in mammals, which is responsible for higher functions like thinking, memory, and emotion. Astrocytes are star-shaped glial cells that provide support and nourishment to neurons in the brain. Ischemic environment refers to a condition where there is insufficient blood flow to an organ or tissue, leading to oxygen deprivation and cell death. Hyperbaric oxygen therapy (HBOT) is a medical treatment that involves breathing pure oxygen in a pressurized chamber. The increased pressure allows more oxygen to dissolve into your blood plasma, which can then be delivered to your tissues. HBOT is used to treat a variety of conditions, including decompression sickness, a condition that can occur after scuba diving or rapid decompression from altitude. Longitudinal studies are observational studies that follow a group of individuals over time to investigate how a disease or condition progresses. In this context of ischemia and astrocyte survival, a longitudinal study might track changes in astrocyte health after an ischemic event like a stroke in a group of patients over weeks, months, or even years. These studies aim to understand the underlying mechanisms of a biological process. Researchers are specifically investigating the role of the C3A protein in promoting astrocyte survival during ischemia. They might use cell cultures or animal models to isolate and analyze the effects of C3A on astrocytes under ischemic conditions. Glutamate is a major excitatory neurotransmitter in the brain, and during an ischemic event reduced blood flow, its excessive accumulation can be detrimental to astrocytes. Glutamate normally interacts with astrocytes, helping them regulate glutamate levels. In ischemia, this interaction becomes dysfunctional, hindering astrocyte ability to clear glutamate and maintain brain homeostasis. The SPRINT Mind trial, this large-scale study, completed in 2016, investigated whether treating high blood pressure more intensively could reduce the risk of dementia. The results were encouraging, showing that a more aggressive approach to blood pressure control led to a modest decrease in the incidence of dementia. This study highlights the importance of vascular health in preventing dementia. A steady-state evoked potential (SEVEP) is the measurable electrical response of the brain to visual stimulation presented at a fixed or flickering rate. When the retina is excited by a visual stimulus flickering between 3.5 Hz and 75 Hz, the brain generates electrical activity at the same frequency or multiples of as the visual stimulus. SSVEPs are typically measured using electroencephalography (EEG), a non-invasive method that records electrical activity from the scalp. Excellent signal-to-noise ratios are much larger than ongoing background brain activity, making them easy to detect in an EEG recording. Relative immunity to artifacts are less susceptible to artifacts caused by eye movements, muscle activity, and other sources of electrical noise. Non-invasive EEG is a safe and painless procedure that can be used in a variety of research settings. Ease of recordings can be made relatively quickly and easily, even in young children or people with disabilities. The Finnish Geriatric Intervention Study to Prevent Cognitive Impairment (FINGER). This innovative study explored whether a multi-domain lifestyle intervention could prevent or delay cognitive decline. The intervention included regular exercise training, dietary counseling, cognitive training, and social activity promotion. After 2 years, the study found that the multi-domain intervention group showed slower cognitive decline compared to the control group. This suggests that lifestyle modification strategies hold promise for mitigating dementia risk. The term simultaneous stimulation most likely refers to a technique used in neurological examinations called double simultaneous stimulation (DSS). A healthcare professional touches corresponding parts of your body on one side, the other side, or both sides at the same time. You, with your eyes closed, identify which sides were touched. This helps assess how well your brain processes sensory information from both sides of your body. It's particularly useful in detecting neglect or weakness on one side, which could indicate damage in a specific area of the brain. Linearity implies steady decline as straight line going down. That's how forgetting might seem. The longer it's been since you learned something, the less likely you are to remember it. Selective forgetting is not uniform in reality. We don't forget things evenly. Some memories fade quickly, while others stick around for years. This is because selective forgetting is nonlinear and more complex, able to trigger recall. Launched in 2004, ADNI uses sophisticated brain imaging techniques, PET scans, MRI scans alongside cognitive assessments and genetic analysis to track participants' progress from healthy controls to mild cognitive impairment (MCI) and eventually Alzheimer's disease. By identifying early biomarkers of the disease, ADNI aims to accelerate the development of effective treatments. The Whitehall 2 study, this ongoing study in the UK, launched in 1985, focuses on the health of British civil servants. Interestingly, recent findings suggest a link between socioeconomic status in midlife and dementia risk later in life. People with lower socioeconomic status were found to be more likely to develop dementia, highlighting the potential role of social determinants of health in cognitive decline. Neurological basis of language refers to the network of brain regions involved in understanding, producing, and learning language. This network includes areas like Broca's area responsible for speech production and Wernicke's area responsible for language comprehension, both located in the dominant hemisphere, usually the left hemisphere for most people. The body's response to language is our nervous system is involved in our senses and physiological responses to language. For instance, hearing a loved one's voice might activate the reward centers in the brain, while listening to something scary might trigger the fight or flight response. The field that studies the relationship between the brain and language is called neurolinguistics. It delves into the neural mechanisms that underlie our ability to comprehend, produce, and acquire language. Neurolinguistics is an interdisciplinary field that draws on knowledge from neuroscience, linguistics, cognitive science, communication disorders, and neuropsychology. Researchers can develop computer models to simulate how the brain processes language. This can help us to understand the complex interactions between different brain regions involved in language. Epistemicism deals with vagueness in language. It argues that vagueness arises from our limitations in knowledge, epistemic limitations, rather than the inherent fuzziness of the concept itself. Semantic plasticity focuses on how the meaning of words and phrases can change over time or context. Epistemicism relies on the idea that there are clear boundaries for vague terms, even if we can't always perceive them. This creates a challenge. How can we have clear boundaries for vague terms if their meaning can subtly change? Some philosophers, like Timothy Williamson, argue that our inability to detect these slight shifts in meaning contributes to our struggles with borderline cases in vagueness. There's ongoing debate about how epistemicism and semantic plasticity interact. Some argue that semantic plasticity undermines the core ideas of epistemicism. Semantic plasticity lays the foundation. Pragmatic plasticity utilizes that foundation. We use our understanding of context and speaker intent to interpret the meaning beyond the literal definition. Semantic dementia is a form of frontotemporal dementia that primarily affects areas of the brain responsible for language processing. This can lead to a variety of early signs related to difficulties with understanding and using language. People with anomia may have trouble finding the words they want to use in conversation. They may know the general concept of what they want to say, but they just can't come up with the specific word. They may also start to substitute incorrect words for the ones they're trying to say. As the disease progresses, people with semantic dementia may start to have difficulty understanding spoken language. They may have trouble following conversations or understanding humor. People with semantic dementia may also develop problems with reading. The Demerits potential, also known as the readiness potential (RP) or premotor potential, is a phenomenon in neuroscience. It's a measure of brain activity in the motor cortex and supplementary motor area that happens right before you make a voluntary movement. Involuntary seclusion is the practice of confining a person, typically a patient in a mental health facility or nursing home, alone in a room from which they cannot leave. It is a controversial practice, with concerns raised about its potential for abuse and its effectiveness as a therapeutic intervention. There are strict guidelines around when involuntary seclusion can be used. It is generally only considered a last resort, when a person poses a threat to themselves or others, and all other de-escalation techniques have been exhausted. The decision to use involuntary seclusion should be made on a case-by-case basis, taking into account all of the relevant factors. It is important to weigh the potential risks and benefits of seclusion carefully before making a decision. Light acts like a wave or particle. We decide after it travels which to see, somehow affecting its past behavior. In quantum mechanics, the very fabric of space might be filled with constantly fluctuating energy, even in a seemingly empty vacuum. The Rush Memory and Aging Project, this ongoing study began in 1997 and follows a diverse group of older adults. It incorporates regular cognitive assessments, brain imaging MRI scans, and blood tests to track changes over time. The project has identified several modifiable risk factors for dementia, including midlife hypertension, low education levels, and social isolation. By understanding these factors, researchers can develop interventions aimed at mitigating risk. In the context of sleep, N1 waves refer to the first stage of non-rapid eye movement (NREM) sleep. It's also sometimes called non-rapid eye movement 1 (NREM1) or drowsiness. NREM sleep is characterized by slower brain waves compared to wakefulness. The visual N1 is a type of event-related electrical potential (ERP) that is produced in the brain in response to visual stimuli. It's part of the visual evoked potential (VEP). The N1 is a negative going deflection that typically occurs about 100 to 150 milliseconds after the presentation of a visual stimulus. The amplitude and latency of the N1 can be influenced by a variety of factors, such as the size, intensity, and novelty of the stimulus. While MRI provides a snapshot of the brain's structure, N1 waves offer a window into its function during language processing. By combining the information from both, researchers can gain a more comprehensive understanding of language disorders. Atrophy and aphasia are closely linked. Aphasiology is the study of language disorders caused by brain damage, and atrophy is the wasting away or shrinkage of an organ or tissue, including the brain. Atrophy can damage brain regions crucial for language processing, leading to aphasia. Difficulty speaking fluently, but comprehension may be relatively preserved. Difficulty understanding spoken language, and speech may be fluent but nonsensical. fMRI functional magnetic resonance imaging and PET positron emission tomography scans are two important tools used in neurolinguistics research to examine brain activity related to language. While both techniques offer valuable insights, they measure different aspects of brain function. In some cases, researchers may even use combined PET-fMRI scans to obtain a more comprehensive picture of brain activity. This technique allows researchers to simultaneously measure changes in blood flow fMRI and metabolism PET in the brain. fMRI is preferred when high spatial resolution is needed. PET scans are preferred when high temporal resolution is crucial. Negative peaks N100 auditory, a negative deflection in the ERP waveform occurring around 100 milliseconds after an auditory stimulus. It's associated with basic auditory processing in the brainstem. N200 visual, a negative deflection around 200 milliseconds after a visual stimulus. It's thought to reflect early visual processing stages. N2PC attention, a negative deflection related to attention. It occurs around 200 milliseconds after a stimulus in the unattended field shifts, suggesting a suppression of processing in that location. N170 face processing, a negative deflection around 170 milliseconds after a visual stimulus, particularly strong for faces. It's thought to reflect neural activity related to face recognition. N400 semantic processing, a negative deflection around 400 milliseconds after a word or sentence that violates semantic expectations, e.g., "The cat drank the house." It suggests the brain is processing the meaning of the stimulus. Visual N1 similar to N100, this term might be used interchangeably with N100 in the context of visual stimuli, but it can be less specific. Positive peaks P. C1 auditory, a positive deflection around 50 to 70 milliseconds after an auditory stimulus. It's associated with early auditory processing in the brainstem. P1 visual, a positive deflection around 100 milliseconds after a visual stimulus. It's thought to reflect early visual processing stages. P200 attention or semantic processing, a positive deflection around 200 milliseconds after a stimulus, sometimes associated with attention or semantic categorization depending on the task. P300 decision-making or novelty, a positive deflection around 300 milliseconds after a stimulus that requires a decision or is particularly novel or unexpected. P3 auditory novelty, a specific subtype of P300 associated with processing novel or unexpected auditory stimuli. P3B decision-making, another subtype of P300, this one related to making decisions or classifications based on the stimulus. P600 syntactic processing, a positive deflection around 600 milliseconds after a word or sentence that violates syntactic rules, e.g., "The house the cat drank." It suggests the brain is processing the grammatical structure of the stimulus. Event-related potentials are a way of measuring brain activity by recording electrical signals from the scalp. Episodic memory is the memory of everyday events such as times, location, geography, associated emotions, and other contextual information that can be explicitly stated or conjured. Along with semantic memory, it comprises the category of explicit memory, one of the two major divisions of long-term memory, the other being implicit memory. The term episodic memory was coined by Indel Tulving in 1972, referring to the distinction between knowing and remembering. Knowing is factual recollection semantic, whereas remembering is a feeling that is located in the past episodic. One of the main components of episodic memory is the process of recollection, which elicits the retrieval of contextual information pertaining to a specific event or experience that has occurred. Episodic memories are believed to be stored in the medial temporal lobe, which includes the hippocampus and surrounding structures. The hippocampus is particularly important for consolidating short-term memories into long-term memories. The superior angular gyrus is a key player in the neocortex, the outermost layer of the brain responsible for our most complex cognitive functions. The neocortex is like the brain's outermost wrinkly shell, divided into left and right hemispheres. It's responsible for higher-order functions like language, memory, sensory perception, and motor control. The neocortex is further subdivided into different lobes: frontal, temporal, parietal, occipital, with specialized functions. Located in the rear inferior parietal lobe of the neocortex. Superior angular gyrus acts as an integration hub within the neocortex, connecting various regions for complex tasks. Imagine reading a sentence. The visual information from the written words goes to the occipital lobe. The superior angular gyrus then connects this visual information to Wernicke's area for comprehension and Broca's area for potential verbalization. It might also connect to memory regions to access relevant information related to the sentence. When a stimulus is presented repeatedly, the brain's response typically weakens due to a phenomenon called habituation. Evoked redundancy can occur when a stimulus continues to elicit a strong response even though it contains redundant information. This might suggest the information is particularly important or the brain is struggling to process it efficiently. In fields like communication and computer science, redundancy is often used intentionally. For example, data transmission might include error correction codes, which are essentially redundant bits. These allow for detection and correction of errors during transmission. However, excessive redundancy can be wasteful and slow down processing. Evoked redundancy can be a negative aspect in such cases, highlighting unnecessary repetition that could be streamlined. In perception studies, presenting redundant information can sometimes enhance its memorability. However, too much redundancy can also lead to boredom and decreased attention. Evoked redundancy in this context might be used to investigate how humans process repeated information and how it affects learning and memory. The somatic sensory cortex is a region of the brain responsible for processing touch, pain, temperature, and proprioception body awareness. It's located in the parietal lobe of the brain and receives signals from the entire body through the thalamus. The somatosensory cortex is like a map of the body, with different areas dedicated to processing sensations from specific regions. For example, there's a larger area for the hands and lips, which are more sensitive than other parts of the body. The endocannabinoid system (ECS) is a complex network of receptors, enzymes, and molecules that are naturally produced by the body. The most well-known cannabinoids are THC and CBD, which are found in the cannabis plant. However, the body also produces its own cannabinoids, called endocannabinoids, which bind to the same receptors as THC and CBD. The ECS can modulate sensory perception in the somatosensory cortex. Also plays a role in synaptic plasticity, which is the brain's ability to change and adapt. The embryonic nervous system is a structure that begins to develop very early in pregnancy. In fact, the first signs of the nervous system can be seen in the third week of development. The ectoderm, which is the outermost layer of cells in the early embryo, the neural plate then folds inward to form a tube-shaped structure called the neural tube. The neural tube will eventually become the brain and spinal cord. The neural tube continues to develop and differentiate into different regions. The rostral upper end of the neural tube will become the brain, while the caudal lower end will become the spinal cord. The brain and spinal cord continue to grow and become more complex. Neurons' nerve cells begin to develop and migrate to their final positions. Axons, the long fibers that extend from neurons, and dendrites, the shorter fibers that receive signals from other neurons, begin to grow and connect with each other. In the United States, for example, stem cell research is overseen by the Food and Drug Administration (FDA) and the National Institutes of Health (NIH). The FDA regulates the development and marketing of stem cell therapies, while the NIH oversees the conduct of stem cell research. Similarly, in Australia, The Therapeutic Goods Administration (TGA) is responsible for regulating stem cell therapies. The TGA has developed a framework for the regulation of stem cell therapies, which is based on the level of risk associated with the therapy. Arcuate fasciculus syntax refers to the way the arcuate fasciculus, a nerve fiber bundle in the brain, facilitates communication between brain regions involved in language processing. It's a complex biological pathway, not a set of rules like programming syntax. Imagine a hypothetical nervous system that could dynamically adjust its connections based on experience, similar to how dynamically typed languages adapt to input. Conversely, a static nervous system would be pre-programmed with fixed connections similar to statically typed languages. However, the actual nervous system operates on a more nuanced level, combining elements of both flexibility and predetermined pathways. Endocrine and enteroendocrine pathologies refer to abnormal conditions affecting the endocrine system and the enteroendocrine system, respectively. The vagus nerve, a major nerve connecting the brain to the gut, plays a crucial role in communication. The vagus nerve carries signals from the brain to the gut, influencing dynamic hormone release from enteroendocrine cells. Fiber tracks in the limbic system could include fornix, cingulum bundle, or amygdalo-hippocampal pathway. Basolateral nucleus (BL), this region is believed to be involved in conscious fear processing and emotional memory formation. It's also implicated in social interaction and decision-making. Centromedial nucleus (EM), this subregion processes emotional responses, particularly fear and anxiety. It also plays a role in regulating emotional behavior. Cortical nucleus (CO), the cortical nucleus has connections to sensory areas of the brain. It may be involved in integrating sensory information with emotional responses. Lateral nucleus (LA), this is a less well understood region compared to others. It may be involved in processing unpleasant odors and emotional learning. GABA exerts its inhibitory effects by binding to specific receptors on nerve cells. There are two main types of GABA receptors, GABA A and GABA B. These are ionotropic receptors, meaning that they are directly linked to an ion channel. When GABA binds to the GABA A receptor, it causes the channel to open, allowing chloride ion Cl to flow into the nerve cell. This influx of chloride ions makes the inside of the cell more negative, making it less likely to fire an action potential. GABA B receptors are metabotropic receptors, which means that they are coupled to G proteins. When GABA binds to a GABA B receptor, it activates a G protein, which then triggers a cascade of events that ultimately leads to a decrease in neuronal activity. The binding of GABA to its receptors is a complex process that can be influenced by a variety of factors, including the type of GABA receptor, the presence of other neurotransmitters, and the action of drugs. Effects of chronic exposure. These studies could examine how long-term exposure to certain chemicals or environmental factors might influence GABA levels and their impact on brain function. For instance, a longitudinal study could track changes in GABA function in people who work in environments with high solvent exposure. Developmental changes. Longitudinal studies can track how GABAergic systems develop and change throughout childhood and adolescence. This could provide insights into the role of GABA in brain maturation and potential links to neurodevelopmental disorders. Unlike traditional software development methodologies with a linear flow, extreme programming XP follows an iterative life cycle. This means the process repeats itself in cycles until the final product is complete. This is where the development team meets with the customer to understand their needs. Requirements are gathered and prioritized in the form of user stories. These stories are then estimated and put into a release plan that outlines the functionalities to be delivered in each iteration. The project is broken down into short development cycles, typically 1 to 4 weeks. In each iteration, A small set of user stories are chosen from the release plan. The team then designs, codes, tests, and deploys these features. A core practice in XP is integrating code changes frequently, often multiple times a day. This helps to catch and fix bugs early on in the development process. Multiple WH questions: how many WH quantifier and what WH determiner? Scrambling: which iteration is scrambled for emphasis, departing from the typical subject-verb order. WH quantifier interaction: how many interacts with user stories a noun phrase to ask about quantity. Covered WH movement: we can assume order WH movement has moved to a higher position in the sentence, possibly left periphery, but remains semantically connected to its base position. In what order are they chosen? Testing is a vital part of XP. Automated tests are written alongside the code to ensure functionality and prevent regressions, introducing bugs in new code that affect existing functionality. At the end of each iteration, a potentially shippable product increment is produced. This means the delivered software could be usable by the customer if needed. Customer feedback is continuously collected throughout the development process. This feedback is used to refine requirements and prioritize stories for the next iteration. The XP life cycle is known for its flexibility and adaptability. Since requirements are prioritized and broken down into small chunks, the project can adapt to changing needs or priorities. This approach is well suited for projects with uncertain requirements or where rapid delivery of value is important. Functional sensitivity refers specifically to the lowest concentration at which a test can provide clinically useful results in laboratory analysis. It's a concept used to assess the reliability of diagnostic assays. Analytical sensitivity refers to the lowest amount of an analyte, the substance being measured, that a test can detect. Functional sensitivity goes beyond simply detecting the analyte. It focuses on the minimum concentration where the test can provide a result that's reliable and accurate enough for making clinical decisions. Labs typically establish functional sensitivity by analyzing samples with different concentrations of the analyte. They then assess the precision, how consistent the results are at each concentration level. The functional sensitivity is considered to be the concentration where the precision meets a predetermined threshold, often a coefficient of variation, CV, of less than 20%. Functional sensitivity is not always the same as the limit of detection LOD reported by a test manufacturer. Autism spectrum disorder (ASD) is a complex neurodevelopmental condition characterized by challenges with social communication and interaction, restricted and repetitive behaviors, and sensory sensitivities. One area of intense research interest is the potential role of neurochemical imbalances in ASD. Neurotransmitters are chemical messengers that brain cells use to communicate with each other. It's important to note that research on neurochemicals and ASD is ongoing and the findings can be complex. There isn't a single neurotransmitter imbalance that explains ASD, and the specific neurochemicals involved may vary between individuals. The atypical neurochemical function may be due to underlying genetic or environmental factors. The changes in neurotransmitters may contribute to the core symptoms of ASD, but the exact mechanisms are not fully understood. Research on neurochemicals in ASD holds promise for the development of new treatment approaches. The amygdala's role in processing social cues may be impacted in autism spectrum disorder, potentially contributing to difficulties with social interaction and communication. Early intervention studies. These studies follow autistic children from a young age to assess the impact of early intervention programs on their development. They track changes in communication skills, social interaction, and learning outcomes to see if early intervention leads to better long-term results. Sibling studies. These studies follow siblings of autistic children to see if they are more likely to develop autism themselves. This helps researchers understand the role of genetics and environmental factors in autism risk. The Autism Phenome Project. This large-scale longitudinal study follows autistic individuals across their lifespan. It explores changes in cognitive skills, social functioning, mental health, and daily living skills to understand the long-term trajectory of autism. Eye tracking studies. These studies use longitudinal methods to track how eye gaze patterns in autistic children change over time. This can reveal insights into how they process visual information and develop social attention skills. There's a developing link between dementia, especially Alzheimer's disease, and autism spectrum disorder (ASD). Adults with autism seem to have a higher chance of developing dementia later in life. This is particularly true for Alzheimer's. There's some overlap in how these conditions affect the brain and communication, although it's important to remember dementia is a progressive decline, while autism is a developmental condition present from a young age. This includes potential problems with how brain cells connect and communicate with each other, and even signs of inflammation in the brain. Genetics may also play a role. Some genes linked to autism also increase the risk of dementia. For instance, a specific variant of the APOE4 gene is associated with both conditions. Studies suggest that memory function declines faster in middle-aged adults with autism compared to those without it. It's important to remember, however, that the connection between autism and dementia is still being explored. More research is needed to understand exactly why this link exists. The idea of a microbiome in the brain, and how it might interact with the immune system, is a relatively new field of research. Traditionally, the brain has been thought of as a sterile environment, but recent studies have shown that there are actually a variety of microbes present in the brain tissue. These microbes are thought to play a role in brain development and function, and may also be involved in neurological disorders such as Alzheimer's disease and Parkinson's disease. The exact nature of this relationship is still being studied, but it is an area of research with the potential to revolutionize our understanding of brain health and disease. Language immunity refers to the idea that our brains are naturally resistant to certain types of linguistic information. For example, we may be more resistant to learning a new language if we are already fluent in several other languages. This resistance is thought to be due to the fact that our brains are already wired for certain types of language processing, and it can be difficult to learn new patterns that conflict with these existing patterns. It is possible that there is some connection between language immunity and the brain microbiome. For example, the microbes in our brains may play a role in shaping the way we process language. However, this is just speculation at this point, and more research is needed to determine if there is any real connection. Cellular morphology interpretation focuses on the shape and structure of immune cells themselves. Certain features of immune cells can contribute to their ability to fight pathogens. For instance, phagocytes like macrophages have an irregular shape with extensions that help them engulf and destroy foreign particles. Similarly, lymphocytes have specific surface receptors that allow them to recognize and bind to antigens on pathogens. Perfusion refers to the passage of fluid through the circulatory system or lymphatic system to an organ or tissue. Most commonly, it refers to the delivery of blood to a capillary bed in tissue. Perfusion is essential for delivering oxygen and nutrients to tissues and removing waste products. It is also important for regulating body temperature. Microcirculation refers to the flow of blood through the smallest blood vessels, the capillaries. Capillaries are very thin and allow oxygen, nutrients, and waste products to pass between the blood and the tissues. Macrocirculation refers to the flow of blood through the larger blood vessels, such as the arteries and veins. Arteries carry blood away from the heart, while veins carry blood back to the heart. Perfusion, or blood flow in a tissue, can be indirectly measured using thermal techniques. Imagine you have a piece of tissue, like the brain. When you apply heat to it, the heat will move throughout the tissue. This movement of heat is called thermal diffusion. Thermal diffusion is influenced by two main factors: how well the tissue itself conducts heat, thermal conductivity, and how much blood is flowing through the tissue, perfusion. Blood flow carries heat away from its source, so more blood flow, perfusion, will result in faster heat movement, thermal diffusion. Scientists can measure the total thermal diffusion of the tissue. By knowing the tissue's thermal conductivity, which can be measured separately, they can then use math to separate the contribution of blood flow, perfusion, from the total thermal diffusion. This gives an estimate of how fast blood is flowing through the tissue. This technique is particularly useful for measuring regional cerebral blood flow, RCBF, which is the blood flow in the brain. By applying heat and measuring thermal diffusion, scientists can continuously monitor RCBF in real time. Repression of genes leading to morphological changes. Cells rely on specific genes to maintain their shape. When these genes are repressed, turned off, the cell can lose its normal morphology. For instance, repressing a gene called FTSZ in rod-shaped bacteria can make them spherical. This is something researchers are looking into for engineering cells for specific purposes. Cellular stress causing morphological changes. Exposure to external stressors like sound waves in operation can disrupt a cell's normal functions, including maintaining its shape. This can lead to a phenomenon called morphological repression, where the cell appears deformed or stunted in its growth. Researchers are studying this effect to understand the safety of using sound waves to deliver drugs or genes into cells. In morphology, some morphemes, meaningful units of language like prefixes or suffixes, can block the addition of other morphemes. This essentially suppresses the formation of a specific word form. Sometimes, the absence of a morpheme can be considered a form of suppression. Here's how a blockchain-powered AI system could be applied to autism research and interventions using the concept of morphological immunity. The blockchain could store research findings on potential morphological factors related to autism. Information on interventions that target these morphological factors could be documented. Details on best practices for implementing these interventions and associated patient progress data could be included. Transparency: all recorded information is visible and verifiable on the blockchain, fostering trust and collaboration among researchers. Data cannot be tampered with once entered, ensuring the accuracy and integrity of immutable findings. Security: blockchain technology uses cryptography to secure data, protecting sensitive patient information. The AI component could be used to analyze vast amounts of data stored on the blockchain, identifying patterns and potential connections between morphological factors, interventions, and patient outcomes. However, developing a robust AI for such complex analysis would require significant expertise. Informational communication forms the bedrock of knowledge sharing and understanding. It's a purposeful exchange where the primary function is to transmit facts and equip the receiver with new knowledge. This creates a normative relationship between the sender and receiver. The sender acts as a guide, crafting the message with clarity and structure to ensure the receiver can effectively grasp the information. The receiver, in turn, actively listens and engages with the content, focusing on comprehension. In informational communication, content reigns supreme. Unlike persuasive communication where style and delivery can be equally important, informational contexts prioritize the message itself. This means the sender strives to present information in a well-organized and easy-to-understand manner. They might use definitions, examples, and logical progressions to ensure the receiver can follow the flow of information. Foregrounding refers to linguistic techniques that make specific elements of the message stand out from the background, drawing the reader's attention to the most crucial information. By employing these foregrounding techniques, informational communication goes beyond simply presenting facts. Partial parallelism means things are somewhat similar or happen at the same time, but not entirely. Like sentences that start similarly but then diverge, or computer programs where some parts run simultaneously while others wait, or lab tests where a sample matches a standard curve only within a certain range. It's a limited or incomplete connection. Deviation has a few different meanings depending on the context. In general, it refers to a departure from something expected, normal, or typical. For example, a deviation from the norm could be unusual behavior. In law, deviation can refer to a departure from a standard of care, which can be a component of a negligence claim. Defamiliarization, also known as ostranenie, a Russian term, is a literary technique used to make the familiar seem strange or unfamiliar. It's about presenting common objects, events, or situations in a fresh and unexpected way, forcing the reader to see the world in a new light. The Duhem, Quine thesis, also known as the Duhem, Quine problem, is a concept in the philosophy of science that tackles the challenge of definitively testing scientific theories. Testing a theory in isolation is impossible. Scientific theories rely on a web of underlying assumptions, like the functionality of instruments or the validity of established theories. To test a specific theory, we depend on these assumptions being true. The fault could lie with the theory itself. If an experiment contradicts a theory, it's not always clear which part is to blame. Or maybe an underlying assumption was wrong, or even the experiment might have been flawed. The idea is named after Pierre Duhem, a French physicist, and Willard Van Orman Quine, an American logician, who both elaborated on this concept. Perceptual theory latentness is a specific aspect of the broader concept of theory latentness in philosophy of science. It focuses on how our existing theories and knowledge can influence what we actually perceive. Morphological regression refers to the reversal of changes in size, shape, or structure of a cell, tissue, or organ. It can be a normal process, such as the involution of the uterus after childbirth, or it can be a pathological process, such as the regression of a tumor following treatment. This is a normal process that occurs after a physiological event, such as childbirth or lactation. In involution, cells and tissues that were enlarged or specialized for a particular function undergo a process of shrinkage and return to their non-pregnant state. Histology can be used to identify changes in cell size, shape, and number. Immunohistochemistry can be used to assess the expression of proteins that are involved in regression. Multiple regression is a statistical technique that can be used to analyze the relationship between a single dependent variable, the property you are trying to predict, and multiple independent variables, the factors that you think might influence the dependent variable. Heterophenomenology is a concept in the philosophy of mind developed by Daniel Dennett. Unlike traditional phenomenology, which relies heavily on introspection, heterophenomenology takes a third-person approach, gathering data about someone's mental state from external sources. Additive and shunting models are two approaches used to understand how systems make predictions based on multiple inputs. These models delve into the world of neurons, the information processing units of the brain. A simple additive model might say a neuron sends a signal if the total signal it receives from its neighbors crosses a certain threshold. Shunting models provide a more nuanced picture. They consider additional factors like leakage currents and inhibitory inputs. Imagine these as minus signs in the recipe. They can dampen the overall effect of incoming signals. Additionally, shunting models might include excitatory inputs that act like amplifiers, making it easier for the neuron to fire. By incorporating these complexities, Shunting models offer a more realistic representation of how neurons process information. Supervised learning is like tutoring a student for a math test. You have practice problems with answer keys labeled data. The student solves problems, and you check their work, correcting mistakes, training the algorithm. The goal is for the student algorithm to solve new problems on their own, just like you want the student to answer test questions without your help. This is ideal for tasks like classifying emails spam or predicting house prices. Unsupervised learning is more like giving a student a box of Legos. There are no instructions. The student explores different possibilities, building structures based on their understanding of the Legos. The algorithm does the same, finding patterns or structures within the unlabeled data. There's no direct teaching, the algorithm figures things out on its own. The goal here is to identify patterns or groupings within the data. This is for tasks like grouping customers with similar purchase history for targeted marketing or a more efficient way to represent complex images. Complementary computing suggests there aren't single circuits doing all the work. Instead, different circuits within the neocortex tackle the same information in complementary ways, each highlighting distinct aspects. One circuit might be a master of edges and shapes, while another focuses on color and contrast. Both these analyses are crucial for fully understanding the image. By working together, these complementary computations allow the brain to extract a richer picture from the raw sensory data. Laminar computing focuses on the neocortex's layered structure. It's not just a jumble of neurons, but a meticulously organized system with distinct layers, each performing specific computations. Information travels through these layers in a specific order, undergoing transformations at each step. Lower layers might be the foundation, identifying basic features like lines and edges. As information travels to higher layers, it gets integrated into more complex objects and concepts. These two concepts work together. Discrete phonology refers to the core concept of phonology itself. It deals with the idea that the speech stream, which is continuous and constantly changing, can be mentally categorized into a finite set of distinct units that have meaning in a language. Our actual spoken language is a continuous stream of sound waves. The physical properties of these sounds like pitch and loudness are constantly changing. Phonology is the mental system that analyzes and categorizes this continuous speech stream into discrete units. These units are called phonemes. The discreteness of phonology lies in the idea that phonemes are treated as distinct categories, even though the physical characteristics of the sounds themselves might vary slightly in real speech. The concept of discrete phonemes can seem at odds with the continuous nature of speech. There can be borderline cases where sounds are very similar and it's hard to definitively categorize them. Languages also have allophones, which are slight variations of a phoneme that occur in specific contexts but don't change meaning. Natural language processing acts like a skilled reader, meticulously analyzing and understanding the nuances of human language. It can sift through mountains of text and speech, extracting meaning, identifying emotions, and recognizing patterns. This understanding becomes the foundation for NLG, which takes the role of a creative writer. Natural language generation uses the knowledge gleaned by NLP to craft human-like text. Think of a machine translation system. NLP first delves into the source language, meticulously untangling its meaning and structure. Then, NLG steps in, using this understanding to weave a new story in the target language, striving for clarity and natural flow. Phase locking proposes that these brain oscillations synchronize with the rhythmic structure of speech, particularly focusing on the stressed syllables within words. Parsing the speech stream by aligning with stressed syllables, Brain oscillations might help our brains segment the continuous flow of speech into discrete units. This segmentation is crucial for understanding the meaning of spoken language. The foundations of neural network research, competitive learning, self-organizing maps in stars and masking fields for classification, outstars for spatial pattern learning, avalanches for serial order learning and performance, gated dipoles for opponent processing, perceptual and cognitive development, social cognition, working memory, cognitive information processing, planning, numerical estimation, and attention, adaptive resonance theory art map, store, cortex, span, list. Parse, list TELOS, smart, crib, visual perception, attention, consciousness, object and scene learning, recognition, predictive remapping, and search, BCSFCS, facade, 3D laminart, AFILM, lightshaft, motion BCS, 3D for motion, mode, Vionet, DARTEX, cart, artscan, partscan, dartscan, 3D artscan search, artscene search, auditory streaming, perception, speech, and language processing, Spinet, Artstream, Normnet, Phonet, Artphone, Artword, cognitive emotional dynamics. Reinforcement learning, motivated attention, and adaptively timed behavior, CogEM, START, motivator, spectral timing, visual and spatial navigation, sovereign, stars, 6STARS, GRIDS map, grid place map, spectral spacing, adaptive sensory motor control of eye, arm, and leg movements, VEET, FLIT, VEET right, direct, VAM, CPG, SACRT, TELOS, SAC SPEM, autism, ISTART. Adaptive resonance theory art, proposed by Stephen Grossberg and Gail Carpenter, delves into how our brains learn and categorize information. If the match is good enough, the existing category gets strengthened. The brain might even incorporate details from the new input to refine the category. However, there's a control mechanism called vigilance. This acts like a filter. If the new information doesn't closely resemble any existing category fails to resonate, vigilance prevents inappropriate learning. Finally, if the new information is entirely new and doesn't fit any existing category, art allows for the creation of a new category. This is how we learn about entirely new things. The beauty of art lies in this balance. It allows for continuous learning and adaptation while maintaining stability in our existing knowledge base. We can learn new things, new categories without forgetting everything we already know. Resting state fMRI RSfMRI is a type of functional magnetic resonance imaging fMRI that measures brain activity while a person is at rest, not engaged in a specific task. Unlike traditional fMRI, which requires subjects to perform a certain action or respond to stimuli, RSfMRI allows researchers to study the brain's intrinsic functional organization. During an RSfMRI scan, participants typically lie still in the scanner with their eyes closed or fixated on a crosshair. The scanner measures blood oxygen level dependent bold signal fluctuations in the brain. Bold signal is an indirect measure of neural activity, where changes in blood flow and oxygenation are used to infer changes in neuronal activity. By analyzing these bold signal fluctuations, researchers can identify networks of brain regions that are functionally connected, even when they are not actively involved in a task. These networks are thought to reflect the brain's ongoing processes, such as daydreaming, mind-wandering, and introspection. fMRI studies of schizophrenia have shown that people with schizophrenia have differences in brain activity compared to healthy people. These differences may be related to the symptoms of schizophrenia. For example, some studies have found that people with schizophrenia have less activity in the frontal lobe, which is involved in planning and decision-making. Other studies have found that people with schizophrenia have more activity in the temporal lobe, which is involved in hearing and perception. A study published in the American Journal of Psychiatry followed patients with first episode schizophrenia for several years. It found that while there can be significant initial dysfunction, cognitive function tends to remain stable after the first 4 to 5 years. A meta-analysis examining longitudinal studies found that while some cognitive tasks showed improvement in patients with schizophrenia, performance in others, like verbal fluency, remained stable. Interestingly, the control group sometimes showed similar or even greater improvement, suggesting other factors at play. Schizophrenia is a mental disorder that can affect a person's ability to think clearly, understand reality, and relate to others. People with schizophrenia may experience hallucinations, delusions, and disorganized thinking. Cognitive decline is a general term for a decrease in mental abilities, such as memory, learning, and problem solving. There is a complex relationship between schizophrenia and cognitive decline. Many people with schizophrenia experience cognitive impairment, which can be present before the onset of psychosis. This cognitive impairment can make it difficult for people with schizophrenia to function in daily life. The course of cognitive decline in schizophrenia is not fully understood. Some studies have shown that people with schizophrenia experience a decline in cognitive function over time, while others have shown that cognitive function can remain stable or even improve. Phonics instruction is like a special tool that can help strengthen that loose doorknob. Now, dyslexia can be like having a loose doorknob on that code. People with dyslexia struggle to connect those written symbols with the sounds they represent. This can make it difficult to learn how to read and write effectively. Sounds come in like instruments playing a song, but with auditory processing disorder, something disrupts how well the brain processes that music. People with normal hearing can hear the sounds just fine, but for someone with APD, it's like the instruments are jumbled or out of tune. Comfort theory by Catherine Kalkaba is a theory from nursing that focuses on meeting a patient's need for comfort across physical, psychosocial, environmental, and spiritual aspects. While not directly applicable to language, it highlights the multifaceted nature of comfort, which can be inspiring when considering how language use can influence a listener or reader's overall experience. A musculoskeletal ultrasound (MSK) ultrasound is a type of imaging test that uses sound waves to create pictures of the muscles, tendons, ligaments, joints, and nerves throughout the body. It is a safe, non-invasive, and painless procedure that does not use ionizing radiation. During an MSK ultrasound, you will lie on a comfortable examination table. A sonographer, a healthcare professional trained in performing ultrasound examinations, will apply a gel to the area of your body being examined. The gel helps to transmit the sound waves. The sonographer will then move a small handheld device called a transducer over the gel. The transducer emits sound waves that travel into your body and bounce back off the organs and tissues. The transducer collects the reflected sound waves and sends them to a computer. The computer uses the sound waves to create images of the inside of your body. Testamentary capacity is a legal concept that ensures someone creating a will, called the testator, is mentally competent enough for the will to be valid. This means they must understand what they're doing. They need to grasp that they're creating a will, know what assets they own, be able to form a plan for distributing those assets after death, and clearly communicate their wishes. Testamentary capacity protects vulnerable individuals. It stops them from being pressured or manipulated into creating a will that doesn't reflect their true desires. It also ensures the legal soundness of the will, avoiding future disputes. The opposite of self-actualization can take a few forms. Self-actualization, on the other hand, is a psychological concept. It describes someone living a fulfilling life, reaching their full potential, and following their values and goals. The opposite of self-actualization is a lack of motivation. Acedia is apathy combined with a feeling of emptiness or lack of meaning in life. Subfusion, a hidden buildup of blood within tissues or organs, can be difficult to diagnose while someone is alive. This is where post-mortem studies, also known as autopsies, come into play. Autopsies act as a window into the body after death, allowing for a meticulous examination of internal organs and tissues. This is crucial for detecting subfusion because it often goes unnoticed during life due to a lack of external signs. Pathologists, medical professionals trained in diagnosing diseases through tissue examination, conduct autopsies. They visually inspect organs for any abnormalities like discoloration or swelling that might indicate subfusion. For example, subfusion in the lungs might cause them to appear a darker red than usual. In some cases, a closer look is needed. Microscopic analysis of tissue samples can be performed to confirm the presence of blood cells within the tissue, solidifying the diagnosis of subfusion. Conclusion: it is naively assumed that the fact that the majority of people share certain ideas or feelings proves the validity of these ideas and feelings. Nothing is further from the truth. Just as there is a folie à deux, there is a folie à millions. The fact that millions of people share the same vices does not make these vices virtues. The fact that they share so many errors does not make the errors to be truths, and the fact that millions of people share the same form of mental pathology does not make these people sane. Eric Fromm. Non compos mentis is a Latin term literally meaning not of sound mind. In legal contexts, it refers to someone who lacks the mental capacity to make sound decisions, understand their situation, or handle their own affairs. This could be due to mental illness, intellectual disability, dementia, intoxication, or other conditions. In everyday terms, sound mind describes someone who is mentally healthy and capable of rational thought and decision-making. They aren't impaired by mental illness, drugs, dementia, or anything else that might cloud their judgment. Synonyms for this include sane, rational, level-headed, and compos mentis, the opposite being non-compos mentis. Empiricism emphasizes basing knowledge on what can be directly observed and experienced. In the case of non-compos mentis, a court would rely on evaluations by medical professionals and potentially witness testimonies to determine if someone exhibits behaviors that demonstrably indicate a lack of mental capacity. Cohen-Grossberg model is a descriptive mathematical framework. It represents the behavior of a specific type of artificial neural network. The model describes how interconnected neurons influence each other's activity levels through mathematical equations. These equations capture the dynamics of how the network evolves over time. Lyapunov function, this is a mathematical tool used for analysis. It doesn't describe the inner workings of the neural network itself. Instead, it helps us understand a specific property of the network modeled by Cohen-Grossberg equations or any other dynamical system. This property is stability. A Lyapunov function tells us whether the activity levels of the neurons in the network will eventually settle at a stable equilibrium point or keep changing endlessly. Nuclear medicine is a field of medicine that uses radioactive materials for diagnosis and treatment. Small amounts of radioactive materials, called radiotracers or radiopharmaceuticals, are injected into the body or ingested. These radiotracers travel to specific organs or tissues, where they emit radiation that can be detected by special cameras. The images produced by nuclear medicine scans can help doctors to diagnose a variety of conditions, including cancer, heart disease, and bone disorders. Nuclear medicine can also be used to treat certain conditions, such as hyperthyroidism and thyroid cancer. In these cases, the radiotracer is used to deliver a high dose of radiation to the targeted tissue, destroying abnormal cells. Nuclear medicine is a safe and effective way to diagnose and treat a variety of medical conditions. The amount of radiation used in nuclear medicine procedures is very small, and the risk of side effects is low. Radiologists don't just rely on written reports to convey medical information. They are experts in extracting meaning from medical images themselves, which acts as a form of non-linguistic communication. This process involves several key steps. Firstly, radiologists choose specific protocols to capture the images. These protocols determine things like camera angles, radiation dosage, and the use of contrast agents. By fine-tuning these settings, radiologists ensure the images provide the most relevant information for the situation. Next comes image interpretation. Radiologists meticulously examine the images for abnormalities. They compare features like size, shape, density, and signal intensity to what's expected in healthy anatomy. Their knowledge of anatomy, physiology, and disease allows them to interpret these findings in relation to the patient's specific medical history. Finally, radiologists share these images with other healthcare providers involved in the patient's care. Picture archiving and communication systems PACS facilitate the electronic storage, transmission, and viewing of these images. Alfred Korzybski, a Polish scholar, proposed a theory of sanity within his concept of general semantics. This theory, outlined in his book Science and Sanity 1933, focuses on how language shapes our understanding of the world and how we can improve our mental well-being by using language more thoughtfully. The map isn't the territory. We don't directly experience the world, we experience it through abstractions like our senses and language. A map helps us navigate, but it's not the actual land itself. Korzybski challenged traditional thinking that often relies on binary options either or. His theory suggests a more nuanced approach. Things can be both A and not A to some degree. For instance, a situation can be both challenging and an opportunity for growth depending on your perspective. A cup can be both half full and half empty depending on your perspective. Lyapunov time, named after the mathematician Alexander Lyapunov, is a concept used in chaos theory to describe the predictability of a dynamical system. It essentially tells you how long it takes for a chaotic system to become unpredictable, even if you start with very similar initial conditions. Lyapunov time quantifies the sensitivity to initial conditions in chaotic systems. It's the time it takes for nearby trajectories to diverge significantly. The Lyapunov time tells you how long it takes for these initially close paths to become significantly different, making future predictions about their positions unreliable. Lyapunov time is typically measured in the same units as time itself: seconds, minutes, etc. A larger Lyapunov time indicates a more predictable system, where small differences take longer to become significant. Conversely, a smaller Lyapunov time signifies a highly chaotic system where even tiny variations quickly lead to very different outcomes. References and citations. Curva, A. G. Sabe, L. Kuzis, G. Tiberty, C. Dorigo, F. N. Starkstein, S.E. 2001. Theory of Mind and Pragmatic Abilities in Dementia. Cognitive and Behavioral Neurology, 14.3, 153-158. Novak, I.A. and Posada, A. 2003. Characterizing the Time Course of an Implicature, an Evoked Potential Study. Brain and Language, 85-2, 203-210. Hayes, S. J. Niven, B. Godfrey, H. and Linscott, R. 2004. Clinical Assessment of Pragmatic Language Impairment, a Generalizability Study of Older People with Alzheimer's Disease. A Faciology, 18-8, 693-714. Newland, M.S. and Kuperberg, Gr. 2008. When the Truth is Not Too Hard to Handle, an event-related potential study on the pragmatics of negation. Psychological Science, 1912, 1213-1218. Igorova, Ensterov, Y. and Pulvermuller, F. 2013. Early and Parallel Processing of Pragmatic and Semantic Information in Speech Acts, Neurophysiological Evidence. Frontiers in Human Neuroscience, 7, 86. Lee, T.K., Q. Ramani, H. Ho, R. E. Ding, H. and Liu, J. 2021. ElseNet, Elastic Semantic Network for Continual Action Recognition from Skeleton Data. In Proceedings of the IEEE CVF International Conference on Computer Vision, pages 13434 to 13443. Kuperberg, Gr. 2007. Neural Mechanisms of Language Comprehension, Challenges to Syntax. Brain Research, 1146, 23-49. Garcia Blas, J. and Carretero, J. 2023, May. Exascale Programming Models for Extreme Data Processing. In Proceedings of the 20th ACM International Conference on Computing Frontiers, pages 279-284. Donaghy, P. C. Barnett, N. Olson, K. Taylor, J. P. McKeith, I. G. O'Brien, J. T. N. Thomas, A. J. 2017. Symptoms associated with Lewy body disease in mild cognitive impairment. International Journal of Geriatric Psychiatry, 3211, 1163-1171. Spreng, R. N. Demas, E. Mwilamwichwilabo, L. Dagger, A. Kohlinger, P. Nave, G. and Bstock, D. 2020. The default network of the human brain is associated with perceived social isolation. Nature Communications, 11-1, 6393. DeVico, G., and Carella, F. 2012. Morphological Features of the Inflammatory Response in Mollusks. Research in Veterinary Science, 93-3, 1109-1115. Chu, Q. Feng, C. and Damien, M.F. 2021. Interference effects of phonological similarity in word production arise from competitive incremental learning. Cognition, 212, 104738. Peng, P. Fuchs, D. Fuchs, L. S. Cho, E. Elliman, A. M. Kearns, D. M. Patton, S. and Compton, D. L. 2020. Is response no response too simple a notion for RTI frameworks exploring multiple response types with latent profile analysis? Journal of Learning Disabilities, 53-6, 454-468. Ballmer, A. 2021. Painting with Data, Alternative Aesthetics of Qualitative Research. The Sociological Review, 69-6, 1143-1161. Kurdi, M.Z. 2024, May. Dementia Detection with Phonetic and Phonological Features. In the International Flares Conference Proceedings Volume 37. Del Fabro, M. Bajan, C. and Taschieri, S. 2009. Immediate implant placement into fresh extraction sites with chronic periapical pathologic features combined with plasma-rich in growth factors, preliminary results of single cohort study. Journal of Oral and Maxillofacial Surgery, 6711, 2476-2484. Liu, Xizhang, Weitang, W. Wang, B. Wang, B. and He, S. 2017. Evoked potential changes in patients with Parkinson's disease. Brain and Behavior, 75, E00703. Rescore Law, M. 2009. Chrysippus Dog as a Case Study in Non-Linguistic Cognition. The Philosophy of Animal Minds, 52-71. Liang, P. P. Liu, Zizadeh, A. and Morency, L.P. 2018. Multimodal Language Analysis with Recurrent Multistage Fusion. AR14 preprint AR14 1808.03920.